Design a low-pass filter using Hamming window to meet the following specification. HD of omega equal to 1 for omega is in between 0 to pi, and it is 0 for pi by 5 less than pi. Use a 10-tap filter and obtain the impulse response of desired filter. Now, step 1. Calculation of HD of n. HD of n. Now we have equation for this HD of n. So it is equal to 1 by 2 pi minus omega c to integration from minus omega c to plus omega ct. It is HD of e raised to j omega n into d omega. So this filter is a 10-tap filter. Given 10-tap filter, therefore m is equal to 10, and this is low pass filter. This is low pass filter. To make the filter realizable, we will add a delay right here. We will add a delay. Therefore, HD of omega is equal to 1 into e raised to minus j omega m minus 1 by 2. This is for pi by 6 to plus pi by 6. Therefore, HD of n is equal to 1 by 2 minus pi by 6 to pi by 6 e raised to minus j omega 10 minus 1 by 2 e raised to j omega n, that is equal to 1 by 2 pi integration minus pi by 6 to plus pi by 6 e raised to minus j 9 by 2 omega e raised to j omega n d omega. Then that is equal to 1 by 2 pi integration minus pi by 6 to plus pi by 6 e raised to j omega n minus 9 by 2, that is 1 by 2 pi e raised to j omega n minus 4.5 into d omega. Therefore, HD of n is equal to 1 by 2 pi j n minus 4.5 e raised to j omega n minus 4.5 raised to values of integration. Now we substitute these values of integration here. So it is HD of n is equal to 1 by pi into n minus 4.5, it is e raised to j pi by 6 n minus 4.5 minus e raised to minus j pi by 6 n minus 4.5 divided by 2j. It is HD of n is equal to 1 by pi into n minus 4.5 sine of pi by 6 n minus 4.5. This is the value of HD of n. Now step 2 is calculation of Hn. Step 2, calculation of h of n. So we have h of n is equal to hd of n into, now we have Hamming window function. We have window function, therefore omega n of n is equal to 0.54 minus 0.46 cos of 2 pi n by m minus 1, that is equal to 0.54 minus 0.46 cos of 2 pi n by 9. Now the range of n is 0 to m minus 1, that is 0 to 9, as m is 1. Now following table gives the calculation of hn. Now next is calculation of hn. So here value of n, this is hd of n. Now hd of n formula is here. Next is omega n of n, formula is here, and next is h of n, that is equal to multiplication of these two. Now the values of n, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, as n goes from 0 to 9. Now for finding the value of hd of n, we have to substitute this n is equal to 0 in this equation here also, and then we have to find this hd of n. Similarly for omega n, we have to write here n is equal to 0, and then we will find omega of n, and multiplication of both these is hn. So here we directly write the answers. So for 0 it is 0.05, it is 0.08, and it is 4 into 10 raised to minus 3. 4 into 10 raised to minus 3. Next is 0.0878, 0.1876, 0.0164. It is 0.46 and 0.0565. Next is 0.15. First we write all the values of hd of n. It is 1647. 47.15, 1229.0878 and 0.05. Next is omega n of n. So it is 0.46. Next is 0.77, 972, 0.972, 0.77. Now here we can see how the values are changes. Up to these 4, the values are these, and after n is equal to 5, the value we get again the same values, that is equal to 0.1155, 0.16, 0.16, 0.1155, 0.0565, 0.0164, and it is 4 into 10 raised to minus 3. So this is the table for calculation of h of n. Next problem, design an FI digital filter to approximate an ideal low pass filter with passband gain of unity, cutoff frequency of 850 Hz and working at sampling frequency of 5000 Hz. Length of the impulse response should be for you. Use rectangular and Hamming window. The problem was asked for the 10 marks in the exam. Now the step 1, calculation of cutoff frequency. Calculation of cutoff frequency, that is omega c. Now given, what is given in the problem? Cutoff frequency it is 850 Hz. Sorry, calculation of not cutoff frequency, calculation of Yes, it is. So sampling frequency, it is 5 fs, that is 5000 Hertz. So fc is equal to 850 divided by 5000, that is 0.17 cycles per sample. So omega c is equal to 2 pi fc. 2 pi into fc is 0.17, that is equal to 1.068 radian per sample. Next step is calculation of HDN. Calculation of HD of n. Now we have HD of omega is equal to e raised to minus j omega m minus 1 by 2. Here m is equal to how much? It is 5, as the length of the impulse response is 5, which is given. So HD of omega is equal to e raised to minus j omega 5 minus 1 by 2. So it is e raised to minus j2 omega. Now HD of n is equal to 1 by 2 pi. It is HD of omega e raised to minus j omega n d omega. So we replace here above values. 1 by 2 pi minus omega c, 1.068 to 1.068. HD of omega, it is e raised to minus j2 omega e raised to j omega n d omega. So we can write this equation as 1 by 2 pi, it is minus 1.068 to 1.068. E raised to j omega is common and n minus 2 d omega. This is equation 1. So HD of n is equal to 1 by 2 pi, it is e raised to j omega n minus 2 j into n minus 2 integration. It is 1.068 to 1.068. Now one by pi into n minus 2, and it is, we take here 2 here and n by 2 outside the bracket. So it is e raised to j omega n minus 2 divided by 2j, values of integration 0.68 to 1.068. So now we replace these integration values in this equation at the place of omega and solve it. So it is